for standard 14. To jot down the triangle. That little symbol in the corner, that's a Greek letter for theta. Theta. We use that for our angles. All right, guys, everybody have this jotted down? Okay. So based on this triangle, what would you tell me the sine of theta is equal to? Like what letter over what letter? Y over R. You guys remember SOHCAHTOA? We talked about this once already, right? Yes? Okay. So sine, remember, opposite over hypotenuse. So Y over R. All right, what's cosine going to be, though? X over R, good, because that's adjacent over hypotenuse. All right, then what's tangent going to be? Y over X, Y over X, that's opposite over adjacent. Okay, those you learned in geometry, you've seen that before, you've done that before, okay? Cosecant, secant, and cotangent, those are new for you guys this year. They are just the reciprocals of your original three. So cosecant goes with sine. So since sine was y over r, this is going to be r over y. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So what do you think secant's going to be? R over x, good. It's hypotenuse over adjacent. And then what's cotangent? Yep, x over y. It is adjacent over opposite. So if you know the original three, as long as you can remember which ones are paired up, it's just the reciprocal set, it's not too bad. You can look at it as you're never going to have cos matched up. Do you guys see how cosine is matched with the only one that's not a co? If that helps you at all. So don't ever put two cos together. Just remember your thing. All right. We're going to use these a lot too, so hopefully that will help you. We talked about that already, so you don't just write that. Okay, I'll give you a second to write down number one here. A point on the terminal side of an angle is given. Find all 6 trig values. All right, so first thing, where is the point 3, 4? If you were going to just plot that point, where is it? First quadrant, right? Like over 3, up 4, so somewhere out here. Okay, it does not have to be perfect. You do not need to be putting tick marks on your axis. You just need the general area. What we're going to do with that point is draw a triangle. Do you guys agree that horizontally I had to go 3 and then vertically 4 to get to that point? Okay. Then I'm going to connect from the origin to my point. That's my hypotenuse. The little theta I was talking about always goes in there. So every single time you guys draw a triangle for me, you have to draw it like this, where the right angle is on the x-axis and the theta is in there by the point 0, 0. Okay, so every single time, right angle to the x-axis. All right. Okay, could you find the length of this hypotenuse? Yes. How? Pythagorean theorem. It's also Pythagorean triple. Do you guys just know what the hypotenuse is? 5. Okay, good. So we'll label that. Once you have it drawn, what I'm asking for is the 6 trig values, meaning I want to know what is the sine of theta. What is the cosine of theta? Tangent of theta. Cosecant of theta. Secant of theta. And cotangent of theta. That's what I'm asking for. So what would you tell me for sine of theta? What'd you say? Yeah, 4 over 5? Okay, good. 4 over 5 is right. What about for cosine? What's cosine going to be, guys? 3/5? Good. What about tangent? 4 over 3. Yeah, opposite over adjacent. Okay. Now, guys, I always write it in the order so they're matching up. So what's cosecant going to be? 5 over 4. What will secant be? Good. And what will cotangent be? Okay. Easy so far? Okay, once you draw the picture, there's not too much to do. All right, let's try again. So same directions here. Now I'm giving you the point -5, -12. So where is the point -5, -12? Third quadrant, somewhere down here, right? Means I'm going left 5, down 12 to get to that. Alright, and then you can connect your point back to the origin. That's where theta is. Drawing the picture matters, guys. You gotta do it right. Okay, also when you're drawing these, the two sides of my triangle are negative because that's telling me the location of the triangle. The hypotenuse will never be negative. Okay, so what do you think the hypotenuse of this triangle is? 13. Yep. Again, that's a Pythagorean triple or a common right triangle. You could certainly do the Pythagorean theorem if you didn't recognize that and find what was missing. All right, guys, so set up for me. Sine of theta, cosine of theta. Let me write them up here. You can check when you're ready. How are we doing? Did any of you leave tangent as -12 over -5? It's not wrong, it's just not simplified. Okay, so make sure if you have two negatives, you make a positive. And now here, I put the negative on the 13, but does that really matter? No, that's just telling me the fraction is negative. I don't care where the negative is. It can be on the top, the bottom, just out in front. It just means a negative fraction, okay? All right. I'll leave that so you can see it, but try C for me. I'm going to have you draw the picture and all of it. You will use the Pythagorean theorem this time to find your missing side. Yes, guys, you do have to rationalize it. And then to find the cosecant, secant, that stuff, don't rationalize twice. Like, think about it. Avoid rationalizing multiple times. It looked like you guys did a good job drawing your triangle, so that's huge. And did you get square root of 5 as your hypotenuse? Okay. So guys, when you initially do like the sine of theta, you get 2 over root 5, right? And then you rationalize that to 2 root 5 over 5. Are we okay with that? When you go to do cosecant, don't flip this one that you rationalize. Look at the original one, because what happens if I flip that? Yeah, you don't have to do anything, right? It's just root 5 over 2. If you flip this one, you have to rationalize and reduce to get to that same answer. Okay? So just do that. Same thing for cosine. So you have -1 over root 5, which is -root 5 over 5. but for flipping purposes, just make it negative root 5. You can put it over 1 if you want to, you don't have to. Tangent, you're just going to get 2 over negative 1. If you write just negative 2, that's fine. Cotangent, negative 1. All right, how are we doing with this stuff? Okay. Any questions so far? All right, let's keep going. All right, I'll let you jot down number 2 here. Given 1 trig value, find the remaining 5 trig values. I'll give you some info. I'll let you write. I'll walk you through this, don't worry. I just want to give you time to write. All right, so instead of giving you an ordered pair, I'm giving you different information this time. I'm telling you what the sine of theta is, and then this weird pi over 2 is less than theta is less than pi. So first, let's figure out what that means. This is telling me where to draw the triangle, okay? We talked about last class how if this is 0 over here where 180 degrees is, do you guys remember how we figured out that was pi? Okay, so where's pi over 2 then? Like at the top where 90 is, right? Okay. So if I am telling you theta, your angle, is somewhere between pi over 2 and pi, do you guys see how that's the second quadrant? Okay, so that's where my triangle is. Again, draw it the same way. Right angle on the x-axis, theta right in there. Okay, side length. I tell you sine of theta is 4 over 5. Well, we know that that is opposite over hypotenuse. So in my triangle, I need to label the opposite side as 4 and the hypotenuse as 5. So what will the other side of my triangle be? 3. How about negative 3? Do you understand why it would need to be negative? You see when we're in the second quadrant, we're going left, which is negative, right? That x value is negative there. Okay, so just be really careful with your signs. You were given sine of theta, so I just need to find cosine, tangent, cosecant, secant, and cotangent. So what is cosine going to be? It's really cold in here today. How about negative 3/5 for cosine? What's tangent? -4/3, good. Cosecant. 5/4. What about secant? And cotangent. 3/4, okay. Those are a little trickier than just giving you the point, but it's still not too bad. Drawing your triangle correctly is crucial. Okay, once you have that labeled right, everything else is pretty simple. All right, let's try another one. Jot down cosine's -12/13. And tangent is positive. Tangent is greater than 0. This is the trickiest kind, where you have to really think about where to draw your triangle. Alright, it's kind of like process of elimination, figuring out what quadrant we're in. So cosine is -12/13. I know that that's adjacent over hypotenuse. Okay, can you guys notice the adjacent is always the x part of your coordinate? Like it's the side-to-side distance that you're traveling. So if that is negative, that means we've gone to the left side of our coordinate plane, right? So what two quadrants could it possibly be in? 2 and 3, okay? I don't know which one, but I know it's got to be in either the second or the third quadrant. Okay, so I've eliminated these two. I cannot draw my triangle there. Then if I look at tangent, it has to be positive. Tangent uses both the opposite and the adjacent. Meaning out of the ordered pair, it uses both the y and the x. Okay? Think about your ordered pairs. In the second quadrant, you have a -x and a positive y. And in the third quadrant, you have a -x and a -y. Which one of those is going to create a positive fraction? The third quadrant, right? The two negatives. Okay, so this is where I've got to draw my triangle. Okay? Erase all that stuff. We're going to practice a bunch of those today, like figuring out the quadrant it fits, because I think that's the hardest part for you. So I know adjacent was -12. Hypotenuse was 13. What does that make the other side of my triangle? Close. -5, right? Do you guys see how it goes down, so it has to be negative? Okay, then we set them up. Sine and theta. They gave me cosine, so I'll jump to tangent. Cosecant. So what's sine of theta going to be? -5/13. Good. What about tangent? It ends up being +5/12, right? So that's a good way to check. The problem told me that tangent needed to be greater than 0. Okay, 5/12 is greater than 0. Then we're just flipping for our remaining values here, so I'll get -13/5, -13/12, and 12/5. Any questions on that one, guys? Do you agree with me that once we're past the drawing of the triangle, it's pretty easy? Okay. Then let's just do some picking of the quadrants, okay? right, so all you have to do is determine the quadrant. So a couple things to think about here. When we have a coordinate, an xy coordinate, the x is always the adjacent part. And y is always the opposite part of our triangle. And remember, the hypotenuse is always positive. So sine, that's opposite over hypotenuse, right? Okay, is the hypotenuse ever going to determine positive or negative for the quadrant? No, because it's always a positive value, right? So really, all you need to think about is the opposite part, or the y value. So look at the four quadrants. Where are the y values greater than 0? Top two, right? 1 and 2. So it's either here or here. Cotangent, remember that's adjacent over opposite. So that's like x over y. It deals with both of them. We need it to be less than 0. In the first quadrant, both x and y are positive. Second quadrant, negative x, positive y. Which one's going to give you a negative fraction when you put them both together? Okay, there you go. That's it. So quadrant 2 is your answer for that one. You can't just look at it and go, okay, it's quadrant 3. Like, you need to process of elimination, work your way through the given information, okay? All right, let's try one more in our notes, and then we'll do some practice. All right, so this time I tell you cosine is greater than 0. Sine of theta is less than 0. So does cosine deal with x or y or both? That's really what you should be talking your way through every time. What's cosine? X or y? X. So where are my x values greater than 0? Which two quadrants? 1 and 4. Good. So it's either here or here. Is sine x, y, or both? Y. So where my y is less than 0 out of quadrant 1 and 4? 4. There you go. Okay. Let's get out whiteboards. You guys want to do shooting game or bluffing game? Shooting. Okay, I like it.